Electric fields, radial fields. So in this nugget, it's going to be really important to remember that opposite charges attract and like charges repel. Charged objects create electric fields that surround them. We are going to look at the electric field around a negatively charged spherical object. An electric field is a region in which an electrical charge will experience a non-contact force. The electric field is represented by black arrows that surround the charged sphere. These arrows are called electric field lines. The shape of this electric field is called a radial electric field. In a radial field around a single spherical charge, the electric field lines meet in the middle of the charged sphere, and the electric field lines are equally spaced around the outside of the charge. The direction of an electric field line indicates the direction a positive charge will move if it is placed at any point on that field line. A positive charge will experience an attractive force in the same direction as the electric field line. The electric field line points towards a negatively charged object, as a positively charged object will be attracted towards it. Now let's look at the electric field around a positive charge. This is also a radial electric field. The arrows on the electric field lines now need to change. Remember, the direction of an electric field line indicates the direction a positive charge will move if it is placed at any point on that particular field line. Pause the video and predicts the direction of the arrows on the electric field line. If another positively charged object interacts with this radial electric field, then the object will experience a repulsive force and will move away from the spherical charge. So the arrows need to point away from the positively charged sphere. Field lines point away from a positively charged object. The electric field also determines the magnitude of the force exerted on a charge that interacts with the field. For a charge at a particular point in the electric field, the size of the force exerted on the charge is determined by the strength of the electric field at that point. The stronger the electric field, the larger the force exerted on the charge at that point. The strength of the electric field is shown by the distance between the electric field lines. Close to the charged object, the field lines are close together, and the electric field is stronger. Further away from the charged object, the field lines are further apart, and the electric field is weaker. So at this point, for example, the electric field is stronger than at this point. The effect of the electric field means that the magnitude of the force between two charged objects is smaller when they are further apart, and larger when they are closer together. Summary. A charged object creates an electric field around itself. Charged objects that interact with an electric field will experience a non-contact force. An electric field is represented using electric field lines. The direction of an electric field line indicates the direction a positive charge will move if placed at any point on that particular field line. Electric field lines point away from a positive charge and towards a negative charge. For a charged spherical object, the electric field is strongest closest to it and weakest further away. This means that the force between two charged objects is largest when they are close together. Keywords. Attract, when objects experience a non-contact force that pulls them closer together. Interact, when something is affected by something else. Magnitude, the scientific term for size. Repel, when objects experience a non-contact force that pushes them away from each other. Radial, lines drawn from a single point that spread further apart from each other. Non-contact, when two objects apply a force on each other from a distance without touching.